So in the previous class we have discussed when a cantilever beam subjected to point load and when a cantilever beam subjected to a UDL. For that we have drawn shear force diagram. Is it right? So we have seen a cantilever beam which is subjected to the UDL, uniformly distributed load, to the entire length. For this, how shear force diagram look like, that's what we have seen in the previous class. So here we will recall once that, then we'll move the further. So the intensity of load, for example, if the intensity of load is 40 kilonewton per meter, and if it is asked to determine what is the shear force diagram and what is the bending moment, then what will be our approach? How we need to approach for this? Anybody here? Is it audible, right? I hope so. It is audible. Ainan Ajit Rathod. Is it audible? Okay. See, for this, how to draw shear force diagram now? Tell me. For the purpose of analysis, what we have done, we need to take some section over here. For example, if you take a section XX here, here a section YY, and if you want to draw shear force diagram for this, let us make sections over here, right? Once you make the section, next we need to determine shear force at each point. That's what we have calculated. For example, shear force which is acting at point B, which is nothing but, what we need to do here, we need to take the intensity of load, that is nothing but 40 kilonewton per meter, and the distance is at point B. Since we are calculating at point B, we don't have any, in the right side we don't have any other loads, and there is no any distance over there. So at exactly point B we are calculating, so distance is 0 over here, and if you multiply with m, meter, so this meter get cancelled, so we left out with 40 kilonewton positive, which is at point B, shear force which is acting at point B.
Sir, 0 kilometers, sir.
Similarly to
Hello, sir.
yes,
So, sir, 0 gonna, sir.
0, okay, 40 into 0 is 0. Here it is 0. Next, here at shear force at point D, tell me, shear force at point, this point, shear force at this point, again 40 kilonewton per meter into the distance is from here to here. For example, if it is 2 meter here, then the answer will be 80 kilonewton, right?
80.
This is positive. Next, shear force at point, shear force at C. Now tell me, shear force at C plus 40 kilonewton per meter into the distance is, for example, if again it is 2 meter, 4 meter over here, so these two get cancelled, so this will be 160 kilonewton.
120.
Similarly, shear force at point A, anybody, 40 kilonewton per meter into the length is 8 meters.
4.
And is, so we are calculating at this point, right? So entire length is 8. So this meter get cancelled, so we left out with 320 kilonewton. So once we calculate shear force at each point, then we need to draw the shear force diagram for this. So how can we draw shear force diagram over here? Shear force for this, let us consider this as A, this point as B, sorry, this point as C, this point as D, this point as B, and the loads which are acting, that is nothing but your UDL. Now take a parallel line to this, take a parallel line. After this, what we need to do? We need to mark, we need to mark A, here we have B, here we have C, here we have D. Clear? Next, what is the intensity of load which is acting at B? Intensity of load which is acting at the B is 0. Here it is 0. So here you can mark it as 0. Next, at the point D. At the point D we have 80. Here you can write 80. 80 in the sense you take a scale and draw a vertical line of which shows 80 kilonewton. It shows 80 kilonewton. Similarly, at point C we have how much? So the upward line shows positive direction, and below this reference line we have negative. So this is nothing but a positive 80 kilonewton. Similarly, at point C we have 160 kilonewton over here. So from point C we can measure 160. This is approximately 160. This is 160 kilonewton. Similarly, at point A we have 320. So approximately this is 320 over here. This is 320 kilonewton. So whenever there is a UDL over here, what we need to do? This line should be inclined one. This line should be the inclined line in shear force diagram. In shear force diagram, the line joining it should be inclined one. Whenever there is a point load, sorry, whenever there is a UDL. So this is how the shear force diagram look like for the given problem. I hope now you understood the concept. समझ में आया ना ये सभी? If you have any doubt in this, you can ask, because last class I have explained this. If you have any doubt in this, you can ask now. So in this class I am going to explain how we can draw bending moment diagram for a cantilever beam when it is subjected to UDL. Is that clear? If you have any doubt, you can ask now. Sachin, Vivek, Ajit. Okay. I hope so. You don't have any doubt. Next, for the same diagram, for example, for the same cantilever beam, for the same cantilever beam, when it is subjected to UDL, when it is subjected to UDL of intensity, how much? 80, right? How much it is? 40. 40 kilonewton per meter, and length the length is 8 meter. For this, how we need to calculate the bending moment? Is it audible, right? I hope so it is audible. Ajit, Ainan, Sachin.
Yes, sir.
Yes, sir.
Okay, fine. We need to calculate bending moment for this cantilever beam subjected to the UDL. Now, for the purpose of analysis, what we have done in the earlier time, the same thing we need to do here. First, we'll take some section over here. For example, this is section XX. At this section, what is our bending moment? Again, we'll take section YY. at this section what will be our bending moment. For the purpose of understanding the diagram of bending moment, we do sections. But usually when you go through the problems, we don't do any sections over there. Usually directly we are going to solve the problem. For the purpose of analysis now, to make you understand, we have taken the sections over here. Right? Once you take the sections, next make mark points over there. A B C D. Okay. D. These are nothing but the nodes are the points are cross sections where we need to calculate the bending moment. Section A, section B, section C, and section D. In those sections, we need to calculate bending moment. First, tell me what is moment. Moment is nothing but what is moment? Force into distance. So when you consider this downward force, it will be negative, right? Bending moment is nothing but negative F into X. Is that clear, right? I hope so. You know this force into perpendicular distance. Now I want to calculate bending moment. Bending moment at a point B means what is the bending moment at this point? One second, one second. Okay. We need to calculate what is the bending moment at this point at B. Now tell me how we can calculate now. We should have force and it should be negative and we should have distance, right? These two factors we need at B. At section B we need some force and we need some displacement. What is the force which is acting at here? That is nothing but the UDL. So first thing what we need to do, that UDL need to convert into meter. So 40 kilonewton per meter into the distance is at this place is 0 meter into this distance. This distance is nothing but the force of application of UDL. In the last class I have explained. See here. If there is a UDL, for example, if the length of the UDL is 2 meter and the intensity is 5 kilonewton per meter. Now, here to calculate the what we call bending moment for this, what we have done, first we need to convert this UDL into point load. That is nothing but 5 kilonewton per meter into 2 meter, right? If you do so, you convert in the sense you have converted UDL into point load, right? This is nothing but 5 into 2 is 10 kilonewton. 10 kilonewton will be your the point load. Where this point load acts? This point load acts at the exactly center of this. This point load acts at the center. That is nothing but at a distance of 1 meter from the fixed end. Since it is 2 meter, at the center, in the sense it should be 1 meter. So I hope so you have like in the last class I have explained this. I hope so you know this. क्या होता है इधर? Whenever there is a UDL, first thing is we need to convert UDL into point load. Like if you multiply with the length, you calculated the point load. Now the thing is where this point load is acting. The point load is acting if the UDL is 2 meter, the point load is acting at the middle of that. For example, we'll take one more example here. For example, if you have UDL here, if you have point load here, if the length, for example, length, this is 2 meter, this is 3 meter, this is 2 meter, and here we have 10 kilonewton of point load. If this is 20 kilonewton per meter, then if it is asked to determine what is the bending moment, for example, you consider this as C, this as D, this as A, this as B. What is the bending moment at this portion? What we need to do? First, we need to calculate force and distance, right? The force is nothing but your 20 kilonewton per meter. Since it is UDL, we need to convert into meter. To do that, what we need to do? We need to multiply with the length. The length is 3 meter. Clear? So this is nothing but your force. And into the distance. This distance we need to calculate, right? Where this, what is the distance of this UDL? Since it is acting at the middle. Since it is acting at the middle, the UDL, once you convert the UDL into point load, then we need to think where this UDL, where this converted point load is acting. This should be act at the middle of this. That is nothing but at a distance of 1.5 meter. It should be act. Means if you consider from here to here, it should be act at 3.5 meter. Means we have 2 meter over here and plus 1.5 meter. Means from the free end, it is acting at a distance of 3.5 meter. This is nothing but your perpendicular distance. I hope so now you clear this concept. If you are not clear with this, you let me know. I will explain once again. So this was very like tricky here. समझ में नहीं आए तो और एक बार पूछो और समझाता हूँ मैं. See, you do one thing. You note down this problem. You will understand the concept. You note down this problem. Is it audible? I hope so, right? सबको सुनाई दे रहा है ना? Is it audible?
Yes, sir.
Okay. Note down the problem. Note down the problem. If you are well versed this problem, if you know, if you understand how to solve the problem, you can understand the concept. Write down question number 1. Question number 1. A cantilever beam. A cantilever beam carries. A cantilever beam carries uniformly distributed load and point loads. It carries uniform distributed load and point loads as shown in the figure. As shown in the figure. Draw shear force diagram and bending moment diagram. Clear? Shear force diagram and bending moment diagram. The given figure is like this. At a free end we have load. Approximately in between we have one more load over here and one more load over here. In between this we have the UDL. Here we have UDL. So here the intensity of load is 20 kilonewton, that is point load. Here we have intensity of load is 10 kilonewton. Here at this part we have intensity of load 15 kilonewton, and this UDL, the intensity of load is 12 kilonewton per meter. This is fixed at this end, and the distance from here to here, it is 1 meter. From here to here it is 2 meter, and from here to here it is 1 meter. Note down this problem. Note down this. Note down this. We'll solve the problem. First we'll solve bending moment, then we'll go for the shear force, because the concept we need to understand how we can draw the bending moment over here. Hmm. Jishan. Jishan. Is it audible to you? सुनाई दे रहा ना आवाज तुम सब लोगों को?
यस सर।
जीशान, तुम्हें रेगुलर क्लास को अटेंड हो क्या?
हाँ
मैसेज डालने से पहले पहले क्लास को अटेंड होना क्या? इज इट देयर और नॉट, क्लास है कि नहीं बोल के तुम्हें ग्रुप में डाले नहीं, पहले देखो क्लास को बैठ को देखो, बाद में मैसेज डालो तुम्हें। Okay, fine. Now for this we need to calculate the bending moment and shear force diagram. This is the very simple problem here. To calculate for this, what we need to do, first we need to make the sections over there. What are the sections we need to do here? We need to consider, for example, this is as section A, and this as section B, and this as section C, this as section D. So when you are making the section, make sure that wherever there is a load, there you need to make the sections. Wherever there is a load, there you need to make the sections. Clear? Once you do the sections, the next step is we need to determine bending moment, because as you know that you can calculate easily the shear force. Here we need to calculate bending moment. Once we do the bending moment, we can go for the shear force. Clear? Now, bending moment which is acting at a point D, at this point, bending moment at D, which is nothing but, as we know that for downward acting force, this is minus. As we know that moment is nothing but force into displacement x. Clear? Since we have point load over here, what is the force acting there at point D? At a point D we have minus 20 kilonewton. This is the force into the distance is x. X is nothing but, at this point we don't have any distance, so x is 0. So 20 into 0 is 20, right? It is 0 kilonewton. So at point D we don't have any bending moment. Clear? Now if you calculate the bending moment at the point C, to calculate bending moment at this point, what we need to do? Again, bending moment is nothing but negative F into x, force into distance. Now tell me, what are the forces which are acting here? What are the forces which are acting right to this? That is nothing but, we have 20 kilonewton, which is at a distance of 1 meter. 20 kilonewton, which is acting at a distance of how much? 1 meter. So minus 20 into 20 kilonewton. 20 kilonewton is the force at a distance of 1 meter. 1 meter. Now apart from this, we have this force, right? 10 kilonewton. So again minus 10 kilonewton. So which is here at this point, means it is 0. So you will get the answer minus 20 kilonewton meter. You make sure that it should be meter, because bending moment is nothing but force into distance. Kilonewton meter, kilonewton meter. Clear? Now we need to calculate what is the bending moment. What is the bending moment at the point B, means at this point. What is the bending moment at this point? Now tell me, is it clear? It is audible? सबको सुनाई दे रहा है ना? Is it audible?
Yes, sir.
Because this is the concept where you need to learn here. To calculate bending moment at this point, what we need to do? First, we need to take, first at this point we have 1, 2, and this one 3, and this one 4 forces, approximately 4 forces which are acting to right of this. to the right of this point. First force is 20 kilonewton. That's what I'll write here. As we know that bending moment is nothing but minus F into X, right? Force into displacement. Now, first we'll calculate this force from this force. That is nothing but minus 20 kilonewton. From this point, it is at a distance of how much? Tell me, it is at a distance
3.
of 3 into 3 meter. Clear? Next, minus, again we have this force. This force is nothing but 10 kilonewton. 10 kilonewton into, this is the force. Next we need to have, this is nothing but displacement. From here to here, what is the distance? From here to here, distance is 2 meter. Is it right? समझ में आ रहा है ना सबको भी? Do you have any doubt here? किसी को भी डाउट है तो पूछ सकते हैं अभी. Any doubt over here? Sachin, Umar, Vivek, Jishan. Now,
No, sir.
okay. Now here we have calculated 1, 2. We have calculated. We have seen two forces. Now we have another two forces. Now we'll go to this force. Then we'll go to this force. Now at B we have this minus 15 kilonewton, and which is acting at this point itself, means distance is 0 meter. So entire gets 0. It entire gets 0, right? Next we have one more force, that is nothing but UDL. Now the concept came here. The concept very interesting here. You just note down. It is 12 kilonewton per meter, right? At this point, I will draw here. I will draw here. Here we have the UDL. The length of UDL is 2 meter. The intensity of load is 12 kilonewton per meter. Clear at this portion. Now, what we need to do first for this section? Whenever there is a UDL, what we need to do? We need to convert this UDL into point load, right? To convert this UDL into point load, what we need to do first? First, we need to write the intensity. What is intensity? 12 kilonewton per meter. Into, if you multiply with the length is 2 meter. Now this is nothing but, the entire thing is nothing but your force. This is nothing but your force. Next we need to multiply with the distance. Now as we know that once we calculated the UDL into point load, this point load which is acting at the exactly at the center, this thing you know, which is acting at the center in the sense which is at a distance of 1 meter, means this is our point B, right? This is our point B, this point, this is our point B, this is our point C. So from B it is at a distance of how much? From B it is at a distance of 1 meter. So we need to multiply with 1. I hope so now you understood the concept. अभी समझ में आ रहा है ना सबको भी? क्या अभी नहीं? This is the important. This is nothing but force, and this is nothing but your displacement. So if we simplify this, you will get the answer. You want me to explain once more here? और एक बार explain करेंगे क्या? See, don't be silent. If you are silent, I feel that you know everything. सबको समझ में आया बोल के मैं समझ लेता हूँ. नहीं बोले तो कुछ भी नहीं समझ में आया बोल के समझ लेता हूँ. एक बार प्रॉम्प्ट को करेक्ट को बता दो. समझ में आया बोले तो ठीक है, नहीं तो और एक बार एक्सप्लेन करो वो तो करता हूँ. कॉन्सेप्ट थोड़ा डिफिकल्ट है, थोड़ा डिफिकल्ट बोले तो क्या ट्रिकी है बस. इफ यू अंडरस्टूड दिस कॉन्सेप्ट इट विल बी वेरी इजी. आइनान, उमर फारूक,
Yes, sir.
विवेक, समझ में आ रहा है क्या? और एक बार समझा देना.
आ रहा है समझ.
ओके, और एक बार देख लो, सभी देख लो एक बार, और एक बार सीख. because it is very important. Right? Here we have UDL, right? Here we have UDL. Here we have point load, and here we have point load, and here we have point load. This is section A. This is section A. This is B. This is C. This is D. Now we need to calculate what is the load over here. Here we have how much? Here we have
20.
20 kilonewton. Here we have how much? Let's see.
10
Let's see,
kilometer.
we have 10 kilonewton. Here we have 15 kilonewton, and the intensity of this load is 12 kilonewton per meter. Now, my intention is to calculate bending moment at point B. At point B, we need to calculate bending moment. To calculate bending moment at point B, what we need to do? As we have calculated bending moment at DC, it is very easy to calculate bending moment at B. Bending moment at B. So as we know that bending moment is nothing but negative force into displacement. Now we have how many forces over here? To the right of this we have one force, 2, 3 and 4. We have 4 forces which are acting right to this portion. So we need to consider all these forces. First we'll consider this 20 kilonewton. So minus 20 kilonewton at a distance of how much? We have not mentioned this distance. Okay, fine. This is 2 meter. This is 1 meter. This is 1 meter, right? Now it is at a distance of from here to here. How much? 3, right? It is at a. This is nothing but your force. This is your distance, 3 meter. Next we have minus. We'll consider this force. This force is nothing but minus 10 kilonewton. Clear? Which is acting at a distance of from here to here. It is 2 meter. Next we will consider this force. Next minus, we have 15 kilonewton here, 15 kilonewton, which is at this place, so the distance is 0. So this will be 0. Next we need to consider the UDL. Whenever you are considering the UDL, make sure that first what we need to do, the given UDL should be converted into point load. First, to convert the point load, what we need to do? We need to multiply with the length. What is the intensity of load? 12 kilonewton per meter. This is the intensity into the distance is 2 meter. Now, this is nothing but your force. This is nothing but your force into force into distance, right? This is nothing but your force. What is the distance? Distance, as I told, it is acting at the middle. It is acting at the middle. When you convert UDL into point load, the point load should act at the middle. Middle in the sense it is at a distance of 1 meter from B. It is at a distance of 1 meter from the B. So here it should be 1 meter. Now if you simplify this and tell me the answer. Simplify this and tell me the answer.
104.
104. Huh?
Minus 104.
Okay, minus 104. What is the unit? Kilonewton meter. I hope so. Now it is clear, right? समझ में आ रहा है ना कैसा बोल के? Now anybody can calculate bending moment at A. कौन भी calculate करके बता दो देखेंगे. Still we have 4 minutes.
173 kilo.
How much?
Minus 173 kilo.
Minus 173 kilonewton meter. Okay, very good. Do one thing, like once we calculated this, next we'll go to the drawing. How we can draw the bending moment diagram for this. This is our beam. Right. Now tell me, wherever there are load, you tell me, we'll draw the bending moment diagram for this. Here we have one more load over here, one more load over here, and we have in between we have UDL over here, and the intensity first, this intensity 20 kilonewton. Here we have 10. Here we have how much?
Sir,
Here we have 15, right? What is the intensity
Sir.
of yes.
Last problem, shear force diagram, sir.
Last problem shear force diagram ಯಾವ್ದಪ್ಪ ಇದೆ ಈ diagram ಇದ್ರದಾ so
sir.
for this problem
Yes, sir.
first we'll draw a bending moment diagram. Once we complete that, we'll go to the shear force. Shear force is very easy. Shear force is very easy. First we'll draw bending moment because I want you to understand this. Like once the class ends, you just rejoin again. Clear? If class ends,
Okay.
you rejoin. They go. See, first what we need to take? We need to take a reference line over here. This is the reference line. Once you take the reference line, next step, you should draw the intensity of load at each point. Means here you make note down, this is nothing but point A, this is your point B, this is point C, this is point D. Similarly, you need to copy here. This is point A, this is point B, this is section C, this is section D. Clear? Once you done this, next step, what is the intensity of load at D? D में क्या है load? Bending moment क्या है? We are drawing bending moment diagram. Bending moment at D क्या था? आंसर क्या था? Bending moment at D? Bending moment
0,
at D is 0. ऐसे बोलो बस जल्दी जल्दी फास्ट. Bending moment at D is 0. Next bending moment at C
-20 kilo.
-20 बोले तो वर्टिकल लाइन वो भी क्या है? एक 2 सेंटीमीटर का आना. क्लियर? नेक्स्ट बेंडिंग मोमेंट एट पॉइंट B
-104.
-104 फॉर एग्जांपल एक नंबर आया समझो. नेक्स्ट बेंडिंग मोमेंट एट A -178. Clear? Now see, whenever there is a UDL, why I have written downwards here? Because these are all nothing but minus in the these are in the negative. They are in the negative one. So we have drawn in the downward direction. So here whenever you are drawing bending moment diagram, if there is a UDL, then this should be your parabolic. This should be your parabolic line. ये कैसा रहता है? ये parabolic line रहता है. This should be your parabolic line. Means you will get a quadratic equation. I will tell you how the quadratic equation come here. Quadratic equation कैसा आता बोल के बताता हूँ. So for that you will get a parabolic here. Next, from here to here we have the inclined line. From here to here we have inclined line. From here to here again we have an inclined line. Here what is the intensity here? What is the intensity? At this point we have -173 kilonewton meter. At this point we have -104 kilonewton meter. At this point we have